In this lecture, we're going to explore the fundamental components that make up an Android program. And we're also going to take a look at the UC Virtual Labs, which can make our lives very easy. So first of all, what is Android? Android is a Linux-based operating system and development platform for touchscreen-based smartphones. Android applications are written in Java, typically in an IDE such as Eclipse, with the installed ADT and SDK. Wow, what does that all mean? Well, Java is a programming language, and that's one of the components that we're going to need to write our Android programs, but it's not the only component. First of all, we need some kind of computer. Either a PC or a Mac is fine. This is the major thing that separates Android development from iPhone development. In iPhone development, you have to write your iPhone app on a Mac. You can't do it with a PC. When I talk about plantplaces.com mobile for Android, a lot of times I get the question, do you have it for iPhone? And the answer is no. And then I get the follow-up question, when will it be ready for iPhone? And the trick is that plantplaces.com mobile for Android is something that is free. And I don't own a Mac. And it's hard to justify paying the money to buy a Mac to write software that I'm giving away for free. And also the developer license that goes with it, because if you're doing iPhone development, you have to have an annual $99 developer license. And so that's one advantage that Android has over iPhone, is that you can write an Android app on either a PC or a Mac. So a lot of times when we write a program, we're going to need to pick a programming language. And Android programs are written in the Java programming language. Now, they're written in the Java programming language, but by default, the Java programming language compiles to something called bytecode, which is run in something called a Java virtual machine. And that's not exactly the way it works in the land of Android. In the land of Android, you write the program in Java, but it compiles to something called a Dalvik virtual machine, which is optimized for the mobile phone. So Java is the programming language. We write a program in Java. We compile it. In most Java programs, they'll compile into bytecode, which run in a Java virtual machine. For Android, it will compile into a bytecode that's, well, not bytecode, but it will compile into something called an APK that's run on the Dalvik virtual machine. So Java can do more than just Android. Java is a very functional programming language that is used to write a lot of different applications. If you've used Illuminate Live, for instance, the online courseware, that's written in Java. I'm currently recording this class in something called Screencast-O-Matic. That's written in Java. The Blackboard, blackboard.uc.edu, that's written in Java. So Java is a very multi-purpose language that does a lot of different things. Java alone isn't enough to write our software, though. We also need something called the Android Development Tool plugin, the ADT, in the Android Software Development Kit. So these are enhancements or extensions to Java that are needed to write an Android program. Now, there's something called the Eclipse Ide that glues everything together. So the Eclipse Ide is where we do all our work. It's where we, number one, write our code. Number two, compile. That means take the code and change it from human language to machine language. Number three, debug or run. Okay, so we can actually run our code in an emulator, and we can do that from within Eclipse. Okay? So in a later lecture, we'll take a look at installing Eclipse, but that's kind of we've already gotten a little bit beyond simple at this point. So I want to keep this lecture pretty simple. Let's start by exploring what the Java programming language is. Just at a very high level, without even thinking about Android, what is the Java programming language? And before we can do that, while we're doing that, we have to think about what compiling is. And compiling takes a program and translates it from something that we can read into something that the computer can read. So to understand that, we have to understand a little bit about what is inside of a computer. And so what I'm going to do now is I'm going to go to ucjava.com. And remember our shortcut, type in the domain ucjava, hold control, and hit enter, and that will append the www and the .com. Now, I bought ucjava.com as a URL, and I redirect it to my UC homepage just because it's a lot easier to say ucjava.com than it is to say homepages.uc.edu/tilde-jonesbr. So ucjava.com will take you to the same location. Okay. So I'm going to go to 32IT205, and I'm going to choose Introduction. Okay. So what is a computer? And this is something that I've always asked in my introductory courses, what is a computer? What I usually do is I ask people to raise their hand and say, who has purchased a computer recently? Usually a couple people will raise their hand. I'll ask them a little bit about what computer they bought, and they'll tell me about the computer they bought. Then I'll say, okay, who's bought a mobile phone in the last 6 months? And then most of the class raises their hands. And a mobile phone is really the same thing as a computer. Okay, the definition of software that runs on a computer is input, processing, output. Take some kind of input, process it, generate some kind of output. So computers aren't necessarily smart. It's just that they can run a lot of simple tasks very quickly. And when we run a lot of these simple tasks quickly and we apply some rules around them, we're able to make decisions. So computers do what we tell them to do, and they do it very quickly. So quickly that they can return results to us and do some high-level computations very quickly. Okay? So computers are flexible because they can perform a variety of tasks, but they have to be programmed, and that's what we do. We have to tell the electricity, we have to tell the circuits how to operate. Okay? Okay, so what are the components of a traditional computer and how does that apply to a mobile phone? We'll typically have a CPU. In a traditional computer, the CPU was fairly large and oftentimes generated a lot of heat. Generating heat means it takes a lot of power. That's a big consideration for mobile. We can't have a CPU that's large and generates a lot of heat, because that's going to eat a lot of power, and that is going to consume one of the most constrained resources that we do have on the mobile phone, which is the battery. Okay? So we need processors that are more efficient and use less power. That's a major consideration for mobile phones. Okay? Next we have RAM. This is a single inline memory module, or a SIM, that we would see in a traditional computer. Fairly large. We have that concept of RAM on a phone as well. Again, a much smaller version. Now, on a traditional computer, we'll have a spindle and platter hard disk, one that actually spins and has moving parts. The trick with that is that moving parts can break. Now, in reality, laptop hard drives tend to be very reliable. They do crash, but not very frequently. I have not had, in my history, I think I might have had one die, if even that. I might not have even had one die. But laptop hard drives have moving parts. There is a bit of a performance degradation when you have moving parts. In a mobile phone, many times we will persist data to an SD card, okay, to a solid-state device, which doesn't have moving parts. On a traditional computer, we'll have a motherboard, which is quite big, like this one. And a mobile phone, again, much smaller. So we have the same concepts in a mobile phone, it's just that they tend to be much smaller. Okay, whoops, sorry, going the wrong way here. Okay, so We have to get from our language of English or something English-like to computer language. Computers want to speak in the language of something being on or something being off, zeros and ones. And in the old days, when we programmed computers, we had to program in that language of zeros and ones. But as time went on, we got to more high-level programming languages, where we would have languages that use more English-like words. And then we can convert those words or compile those words to zeros and ones. So we write instructions to the computer in an English-like language. And then in the compilation step, it will turn that English-like language into a set of instructions in zeros and ones. So that's what a high-level language is. It's something more English-like that will convert to these zeros and ones. Okay? So Java is one of these high-level languages, and it's a fairly popular language. Something really interesting. They say the half-life of knowledge in information technology is 2 years. That means every 2 years, half of what you've learned is useless. Okay? It's kind of scary if you're thinking of a 4-year college degree. The half-life of knowledge is 2 years. That's what they told me when I was an undergrad back in the mid-90s, that the half-life of knowledge is every 2 years. And it's very interesting because that's largely held true. A lot of the things I learned back then no longer apply. One thing that surprisingly has applied over a long time is this Java programming language. I will honestly say it has been popular longer than I ever expected it would be, and I really don't see that slowing down much. Java was not taught in school when I was in undergrad. Java wasn't taught, but it started to be more known right after I graduated. So I graduated from Miami in '97, and right after that, Java became very popular. So I latched on. My first Java-based job was in 1998, and I've pretty much been working with it ever since. So while the half-life of knowledge is 2 years, this is one that stuck around. Part of that is because Java is a very capable language. There are a lot of things that Java can do. You can talk across a network. You can connect to a database. You can have multiple threads. In other words, while the user is interacting with the user interface, you can be caching data at the same time. It's very important. It has security built in. Okay? A lot of these things play very well for the mobile phone. So Java's been around since really '95, so almost 20 years at this point. And as it looks out, it has a lot of features that are very important for a mobile phone. Could you imagine having a mobile app without having networking, or without having the ability to store data locally on the phone? These are things that are very important with mobile phones, and that's why Java is a very good language to learn for this. So, what is Java? It's not HTML, it's not JavaScript, okay? It's also followed by a community process. So it's not completely, it's owned by Oracle at this point, but it's really run by the community. Java can be used in many different applications, from Illuminate Live to Screencast-O-Matic to our Android device and even Blackboard. One of the early things that Java did, I'm going to go to thirdfederal.com and look at a mortgage calculator. One of the early things that Java did quite a bit, where'd the mortgage calculator go? Mortgages, let's try this, is it would do mortgage calculator. It would do things like this. How much will my fixed rate mortgage payment be? It will load up a little window here, like so, and it would load some interactive calculator in a browser. So we could say 200,000, 15 years, let's say 3.5%, and then it will calculate our payments. Okay? Oops. Let's try that again. We'll go with 3.5%. Okay, 5.5, and there we go. So before the internet was really as interactive as it was today, this was a common use for Java, the ability to make a little program that would run within a browser. That was really huge in its day. So Java can do quite a few things. A lot of the skills that you learn in this class, you'll be able to reapply in other environments. Okay, so I think that pretty well covers what I wanted to cover there. What I wanted to do next is take a look at a little Java program. Now, initially you think, oh gosh, if I want to do a little Java program, I need to install the Java Development Kit. And you're right, you do. You have to install the Java development software to write a Java program. And we will cover that in another lecture. But right now, we can actually do quite a bit even without Java installed on our computer. There's something that's going to be very handy for us this semester, and it's called the virtual labs. So let me bring over here 1 second. If you go to the easiest way is just to go to cech.uc.edu, and then we're going to search on virtual labs and hit enter. Here's something that's really cool. I click on Virtual Labs, University of Cincinnati. Follow these instructions. What this will let you do is from your home, you can virtually access the labs at UC 24 hours a day, 7 days a week. So you can access software that's pre-installed from your home. Very easy to do. All you need to do is download the software that's appropriate up here, and then follow closely the guideline down below. Okay? Once you've done that, you'll be able to access the lab virtually. What that will do, let me see if I can drag and place this. It will place this icon on your desktop once you've installed the software. Okay? So you install the software. Again, following the steps at this web page, install the software. Next, what you need to do is VPN, open a virtual private network to UC. To get to VPN, just type in your browser, preferably Internet Explorer. It tends to work better in Internet Explorer. https://sslvpn.uc.edu, and then hit enter. Log on with your username and password. That's your standard central login service username and password. And that will open up a secure connection between your computer and UC's network. In other words, it's as if your home computer is on UC's network directly. It's a very nice thing to have. If you need to access any of the UC resources like Lynda or Safari Books Online, many times it helps to have this VPN connection set up. So, again, steps. Number 1, go to cech.uc.edu, search for virtual labs. Okay. Install the software, the virtual lab client, according to the instructions that follow below. Open up that's step number 1. And that will prompt you to restart your computer, by the way, so just be prepared for that. Step number 2, go to sslvpn.uc.edu, log in with your username and password, open an SSL connection, a VPN connection, from your computer to the UC network. Once you've done that, once you've installed the software, you'll have this icon. Then you open up the VPN connection. That's number 2. Number 3, double click on this icon. Okay, and this will start our virtual connection to UC. So one of the instructions that tells you the connection server should be ucvlabs.uc.edu, and choose connect. And now what this software is going to do is it's going to open up a remote connection from my PC at home to the UC Virtual Labs. I'll put in my password. Having this makes online distance learning much, much easier because we have a standard set of software that we can access just by using this virtual lab. And I choose login. Okay, go ahead, choose connect. And we'll give it a moment here. Okay, now pause the recording just a moment for this to come up, but sure enough, what you see here is we've opened a virtual session to the virtual labs. Very nice. So I have, in this window, I have basically a little computer that I can use. So I'm going to choose Start, and I'm going to say Notepad. I'll type in Notepad, okay? Notepad++ will be fine. So we'll click on this, and I don't expect you to know any of this yet, so don't say, oh my gosh, I've never seen this before. But I'm going to write just a quick and dirty Java program that says hello, and then I'm going to compile and run it, okay, using command line tools. Again, you're not expected to know any of this, and you're not even expected to do this. I just want to give you a quick demonstration of how we can use the virtual lab environment. So, to start a Java class, start a Java program, what we'll typically do is we'll type in the class definition line, which will start as public class, and we'll say greeting. And then open curly and close curly. Okay? Public class greeting. Okay? And then within this, I'm going to make what's called a method. A method is something that we do. It's some kind of behavior. The method is going to be public static void main string args. Okay. Open and close paren, open curly, enter, and then close curly. So these are just instructions that I'm writing so far. And once again, I do not expect you to know what any of these are. There'll be plenty of time for us to discuss this. I just want to show you the different steps of writing code, compiling code, running code. That's all we want to get out of this. Within public static void main, I'm going to say system.out.println, and we'll say hello beginning Android. Okay. So see, we have a lot of symbols, but overall it's pretty much human readable. You can see where the open curly and closed curlies fall. See where the open paren and closed parens fall. You see where the open and closed square brackets go, where the open and closed parens go, the open and closed quotes. So not exactly, not a perfect English sentence, but human readable. It's not symbols, it's not zeros and ones. It's fairly human readable. What I'm going to do now is I'm going to choose File and Save. And this is what we're calling the source code. Okay, it's the source that we've written. Okay, so I'm going to choose Save, and we'll go ahead and put this under Brandon Jones. Uh-oh, hopefully I didn't click too much there. Okay, and I'm going to save this as file name. I'm going to say double quote greeting.java and close double quote and save. Okay, so I've written a program. Let's take a look at where I saved this program. So I'm going to go to Computer, and I'm going to go to C, and I will go down, let's see here, Users, and Jones BR. So this is my directory where I've just saved that file, if I remember correctly. I'm going to scroll down, and we see there's a file here called greeting.java. Again, C, Users, Jones BR, greeting.java. Okay, that's the file I created. It's the only real file that's in this directory right now. Everything else is a file folder except for that file called greeting.java. Now I'm going to go to Start, and I'm going to type in CMD for a command window. And by the way, the steps I'm doing now, luckily you're never going to have to do these. We're going to do this all through the Eclipse development environment. I just want to show you an alternate way to do things. You see we're in C Users Jones BR. I'm going to type in dir and hit enter, which will show me everything that's here, and we see there's a file called greeting.java. Okay, now what I'm going to do is I'm going to invoke the Java compiler. This is going to take my source file and compile it. Compile it into a language that the computer will understand. So I'm going to say C:\\\, And then I'm going to say progra tilde 2. Okay, and how do I know this? I just know this because I've worked through this before. I looked for all these paths. Again, I do not expect you to know this. And then I'm going to say J, and I'm going to hit tab. No, didn't like that. Oh, okay. C progra tilde 2. 1 second, please. Let's see. So we're going to look for C. Program files x86. And Java. And JDK 17045. Okay. So C program files Java. Okay, we got it. Okay, we'll go back to my command line here. Okay, Java, JDK 170 underscore 45 underscore 45 bin java c.exe and then greeting.java. Whoops. Okay, so this line is going to actually compile the file that I just wrote. Hopefully I wrote it properly and it will compile properly. If I made a mistake, it won't compile. But let's go ahead and see what happens. So C progra tilde 2 java jdk 17045 bin java cexe greeting.java. I hit enter, I cross my fingers, I hold my breath, and I get nothing. That's actually good. If we get nothing, it means everything happened okay. If we get an error, it will tell us what the error is. Now, take a mental picture of what's up here when I looked at all the files in this directory, because I'm about to do it again. I type in dir, and what we're going to see is there's a new file called greeting.class. This is the compiled version of greeting.java. So I've written the source code, I've compiled the source code. The next thing I want to do is I want to run the compiled class. I want to run the compiled file. So for this, I'll say C:\\, progra tilde 2 again, and then Java, and then JDK 1.7.0 underscore 45, then bin, then Java, .exe. So I'm calling Java, and I'm telling it to run greeting. And then I'm going to hit enter. And with any luck, there we go. Hello, beginning Android. Do you see what it printed out here? Hello, beginning Android. And that's the exact same thing that I told it to print out right here. So that's a very bare bones way to write a Java program and to run a Java program. The good news is, if you're thinking, gosh, what was that progra tilde 2 and bin and blah, 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 what was all that stuff? You don't have to worry about that. That's all taken care of by something we call our Integrated Development Environment, or our IDE. In a future lecture, I'll walk you through how to set up the IDE. But you know what? You might not have to, because if you use this virtual machine, it's already set up for you. You just go to Development, and then you choose Eclipse. And when you choose Eclipse, you have a pre-configured development environment with all the Android tools already created for you. So let me minimize the stuff I was working on here. This will make your life much easier if you have any difficulties trying to set up your Java environment on your own computer. You can just VPN in and use this one right here. So I'm going to go ahead and use this workspace and choose OK. And this is what we call Eclipse, the Android developer tools. And this virtual machine we can use to write our entire program. So We'll cover actually writing an Android program in a later lecture, but I just wanted to show you how to get in and access the virtual lab. And I wanted to show you that it is a fully functional virtual computer that you can use to write an Android program. So we'll pick back up with this next time. We'll actually go in here into the Android IDE and create our Java program. But that's just some basics about what Java is, why we have Java, what kind of things it can do. It's a programming language where we can use some words, some English-like words, to put together a set of instructions. Then we can compile those instructions. And then once we've compiled those instructions, we can tell the computer to run those instructions, and we can get some output based on those instructions. And at the end of the day, that's all a programming language is. So we'll leave it there, and we'll pick back up next time with setting up your environment and creating your first Android program. Thank you.